All right, everybody. Let's start talking about our first group of biomolecules that we're going to focus on. Mainly, this one is going to be the lipids. Number one here it says lipids. Lipids are water insoluble substances. Okay, so we've talked about that before. What does that mean? Insoluble. Insoluble. Well, it means that they're not mixing, right? It's not going to dissolve. It's not going to spread out into solution. It's just not going to do it. So, lipids, we've mentioned before that it comes from the word lipo, the Greek word lipos, for fat. And so fats, and also not talking about just fat cells like would be in a human or an animal, but also oils are fats and different things. So what does oil not mix with? Well, it doesn't mix with water, and the reason is because of its chemical structure. Okay, so it will interact and mix with organic solvents. It just will not work with such a polar solvent as water. Okay? All right. So let's talk about these different ways that lipids show up and how they help and how they are just absolutely invaluable in biological processes. Okay? We've got here A, B, and C. Lipids provide structure of cell membranes. Lipids provide for storage of energy for metabolism in fats. Lipids or derivatives of lipids are found in hormones and some vitamins. And then it says some examples of a few different types of lipids are shown below. They've got some neat diagrams that we're going to get into in just a minute. So let's talk about some examples of lipids, some ways that they are useful, and the different places in which in our body or in other animal bodies that they are used. Okay, so the first thing that I want to talk about is that they can be used to make biological waxes. Okay, now I'm not talking about wax that goes in a crayon. I'm not talking about wax that goes in a candle. I'm talking about if you are out out in the woods, say, and you find some rain that has beaded up on a leaf, then what you're noticing is that the water is not directly absorbed into the leaf. It kind of sits on top and then runs off. That right there, that is a naturally occurring biological wax. Okay, and it protects the leaves from drowning, basically, from having too much water input, and also from drying out, from having too much water output, losing too much water to the environment. So it really helps with that equilibrium in the leaf. Also, lanolin. I don't know if you guys have heard this word. Lanolin. Lanolin. Yeah, there it goes. That is actually a naturally occurring wax that will coat sheep's wool. Okay? And so these are just naturally occurring oily substances, waxes, that have very, very important biological processes that they support. Well, think about, let's be gross here for a minute. Think about earwax. Okay? What's the purpose of earwax? Well, if you have this sticky substance in your ear, it's hard for something foreign to get in there and cause trouble, right? So that is a protective measure that our body has developed against, foreign foreign creatures, bugs or something living in our ear canal. So, you know, good talk. All right, so let's talk about also the terms triglycerides and like saturated and unsaturated fat. These are things that are talked about a lot of times in reference to health and diet. When you say the word tri, T-R-I, T-R-I, that means 3, okay? Triple, and all that kind of stuff, that prefix, that means 3. So, when you start talking about fats and oils, we're referring to things that have 3 sets of identical fatty acid side chains. So when you look at the structure of these molecules, you will see that they have 3 matching sets of, for lack of a better term, like tentacles coming off the sides. They have 3 sets that exactly match, and this is what contributes to the stability and how they react with things. All right. So, what's one of the differences between fats and oils? Well, oils are typically liquid at room temperature, right? If we think about oil, like vegetable oil, whatever, we think about it, being like in a bottle. We can pour it out. And if we think about a fat, say whenever you cook meat or something and drain off the grease, quote unquote, the fat, when that cools to room temperature, normally it is a solid. It's kind of a gushy solid, but normally it's a solid. So those will also help with some of your visualization things. Okay. All right. So let's go ahead and let's also talk about phospholipids. Okay. Phospho here. Phospho. It means that it has a phosphorus. Let me see if I can squish this in. Phosphorus. That was supposed to be you. Phosphorus. Okay. Means it has a phosphorus atom attached. Okay. So if we talk about phospholipids, we're talking about a string, this fatty acid chain, this group that tells us exactly what it is and how it's going to work. And we're talking about it having a phosphorus group attached. Okay, so let's talk about now, let's talk a little bit about and use our diagram that it's given us, okay? So I'm swapping to the next page. Oh, good, you can see that. All right, now, so what we have here is you can see in the top picture, you can see the phospholipid is the first thing. It almost kind of looks a little bit like a squid because it has a very specific like head part and then the tentacles of the fatty acid chains coming off the backside. Okay. So here, let me see if I can. Okay. Here is the head of the squid. This is the polar part. I guess I don't need quotes for that. Because this is actually going to help it orient itself correctly in when it forms the cell bilayer. Okay. Now, if you look here, lipid bilayer, we've got all the heads on the outside. Okay. And all of the tails are on the inside. Heads outside because they're polar. Tails are inside. because they are nonpolar. That's where the fatty acid chains actually will will reside, is between those two polar heads. And then why is this called a bilayer? Because we have two sets, right? Bi here means two, okay? And they are facing away from each other again. The polar heads facing to the outside, the tails in the middle for stability purposes. Okay, so why do we do this? Why does this work this way? Why is this a preferred method of stability? Okay, well, this is why right here. Is because you see these green things where it says transmembrane protein. Okay, all through the cell walls of animal cells that do not, well, I'm sorry, not the cell walls, but the cell membranes of animal cells, we have these transmembrane proteins that serve lots of different functions. So transmembrane protein can serve for water regulation, waste disposal, okay? It can serve to gather energy, okay? So these are like the little channels in and out of the cell itself, okay? So anytime that something has to come into or go out from the cell, it's going to go through these lipid bilayers, and it's going to have a specialized channel that allows it to do that. And one of the ways that we protect these specialized channels is with this phospholipid bilayer. That is what these are all embedded into. That is how we have the structure of the cell membrane itself, and that's basically what makes everything work. Okay, let's go on down to our next page. Okay, it has a couple of websites on here if any of that interests you. Okay, we are not going to talk about carbohydrates today, so I'm going to draw a line across here, and this one is going to be 3, 31, 20, but we're not quite done yet. I know that I'm getting close to 15 minutes. I'm at 13 right now, so I will try to make sure that I am using my time wisely. All right, so let's also talk about fat-soluble vitamins. Okay, I don't know how much, we haven't really talked much about this up to this point. Fat-soluble vitamins. Okay, so fat-soluble meaning dissolves in fat, right? We've talked about what soluble means. So what would be the benefit of a fat-soluble vitamin, and what is the alternative to a fat-soluble vitamin? Well, the alternative is a water-soluble vitamin, okay? As you can imagine, vitamins, say, like vitamin C, which is a water-soluble vitamin, is something that comes into your body, dissolves in the water of your body as you've ingested it, and can also be excreted in the water from your body. Okay, it doesn't necessarily hang around. It's not something like calcium that gets stored in bones or anything like that. Vitamin C is something we have to eat every day because we just don't hang on to it. Okay, so when we're talking about fat-soluble vitamins, we're talking about A, D, E, and K. Okay, so these vitamins here, vitamin D is super important in calcium usage, making sure your body can actually make use of the calcium you ingest. Vitamin E is an antioxidant, okay? So we've talked about oxidation, how it's a reaction with oxygen, and how we sometimes need to slow that down because oxygen can be corrosive, and stuff like that. Vitamin K is helpful in clotting. Vitamin A helps fight off, it helps your vision, helps fight off night blindness and things like that. Okay, so these are useful vitamins. These are vitamins we need to be able to hang on to. So how could we possibly hang on to these things? Well, if they're not going to, if we can't have them dissolve in water because they won't hang around, we won't be able to use them properly, then we've got to figure out a longer term way to store that. And one of the ways that we can do this is by storing it in fat. So these vitamins, this vitamin structure actually works to store itself within the fat cells, okay? So that way when your body burns off some fat, it can release the stores of these particular vitamins and your body can still use it, okay? And that allows us to hang on to this so that you can use it in the future, okay? Let me go back and see real quick. Provides storage, energy, lipids found in vitamins, some hormones. Okay, all right. I do believe I have covered everything. So 17 minutes, not too bad. I'm going to go ahead and create the questions for this assignment. And I hope you have a great and wonderful day.